this is a series of precipitation reactions or possible precipitation reactions. In each case, we will have two solutions. Now, the fact that they're solutions means that the things in them are soluble, because they wouldn't be solutions otherwise. So the common ion that we're going to use, or the common solution, is calcium chloride. So I'm going to put about 2 mil, just one of these pipettes worth of calcium chloride in each of these 6 test tubes. So that will be enough to actually see. One of the things that we often do in chemistry is do micro scale or quite small scale. I could have filled the test tubes up, but it's essentially a waste of chemicals and chemicals that need to be disposed of and so on. So it makes sense to use small amounts if that's all we need to see. So in this case, I'm going to combine it with a number of different ions and or different solutions. So in this case, copper sulfate. So what we've got is, in the test tube, calcium ions and chloride ions in solution. In the bottle, copper ions and sulfate ions. Sulfate is a combined ion, SO4+, and if there is a reaction, then what's going to happen is either the calcium will get together with the sulfate, or the copper will get together with the chloride. So if either copper chloride or calcium sulfate is insoluble, we'll get a precipitate. If both of those products, both of those potential products are soluble, we won't. So I'll add just a splash of this, it's a blue colour, and give it a stir. But you can see it hasn't precipitated. It's all still in solution. There are no solids there. So that particular first trial, we didn't get a precipitate. That's helpful because it tells us what things are and are not soluble. So we'll do a second one. So still calcium chloride in the test tube, but silver nitrate. So again, same kind of deal. It's either silver chloride is insoluble and causes a precipitate, or calcium nitrate. Now we know actually that most nitrates are soluble. So if we get a precipitate, and we do, we get that kind of chunky white precipitate, then we know that that's a silver chloride precipitate. And in fact, silver nitrate is a test for chlorine in drinking water. If you want to know whether there's much chlorine in the water you're drinking, dropping some silver nitrate in as a test, don't drink the water after it's got silver nitrate in it, is a good test. So we've got that silver nitrate precipitate. Silver chloride precipitate from the silver nitrate. Calcium chloride again, and ammonium oxalate. So in this case, the ammonium, NH4+, we have a positive ion that's compound, not just a metal. And oxalate, I have to admit I can't remember the full formula. It's an organic substance as the ion. And we'll see whether, again, calcium oxalate or ammonium chloride is a precipitate, and indeed it is. We've got a similar looking chunky white, slightly yellowish precipitate there. It looks a bit finer than the silver one. If you compare them, it is a different colour, slightly. The silver one is very white. Of course, silver chloride was used in photography quite a lot. It is black in some situations and white in other situations. So we'll do lead nitrate. So again, a nitrate is probably soluble, the calcium nitrate. In fact, we already know calcium nitrate's soluble because we just did something with a nitrate before and didn't get a precipitate. But the lead chloride may not be, and indeed isn't. So we get a precipitate there. I probably need just a slightly bigger sample. This dropper is not capacious, so we'll add just a fraction more of that. We're getting a small precipitate, but it's kind of dissolving straight away again. In fact, by the time I got back to it, there was no precipitate left. So it seems as though there's something that's not enormously soluble, but soluble enough that we can dissolve that much of it in the solution. So I think there's some very small fine grains there, but most of it's actually redissolved in that case. Sodium phosphate is the next one that we'll do. And there'll be a list of these. So sodium phosphate with the calcium chloride. And we get another kind of whitish precipitate. Now, this is perhaps a little tedious, getting a lot of white precipitates. The challenge is that there are chromate, dichromate, other substances that give us really, really colourful and impressive looking precipitates. The challenge with those is that they are quite dangerous. So we tend not to keep them in school labs these days. In the olden days, there were many of those around, but they are quite nasty chemicals. Now, the last one I'm going to do, so I've got 5 bottles here and 6 test tubes, is I'm going to take the copper sulfate and I'm going to get rid of the copper chloride, calcium chloride in this case. I think that'll work. In that last test tube, I'm going to take the copper sulfate and combine it with one of our other substances. See whether we can get a blue precipitate of copper in this case. So, which of these do we think is the most likely? Copper, it's not going to be one of the nitrates because we know that the nitrates are soluble. So let's give it a shot with the ammonium oxalate. So what we hope is that our ammonium chloride, we know is already soluble, but our copper oxalate does indeed give us a bluish precipitate. So you can see the blue colour. It's a cloudy, milky blue, but there's definitely a blue precipitate there of calcium oxalate in that last one. So in each of these cases, in some of them, the potential products were insoluble and fell out of solution. So what you would have remaining in solution is the other 2 ions. But in others, both of the potential products were soluble, so you end up with just a mix of the 4 ions in solution and it just continues in that state.